The world's future demand for oil is estimated to increase, yet new oil discoveries are decreasing in frequency. Despite the continuous development of technologies, oil exploration remains a high-risk business. Traditionally, seismic analysis has been used to map structures and sediments for their potential to hold oil. Conventional seismic analysis studies how sound waves reflect from geological features in the Earth. This is useful for mapping geological structures and supportive conditions for an oil-filled reservoir. But conventional technologies can't reveal if a reservoir really holds oil. Up to today, the global average success rate for oil exploration remains at 10 to 15%. Since 2009, the founders of Rex International Holding have been dedicated to finding more accurate ways to explore for oil. Being scientists and entrepreneurs, they thought outside the box. They found that acoustic resonance identified in seismic data can help the oil exploration process. Resonance is the naturally occurring phenomenon that happens when a sound wave makes another matter vibrate. A pattern emerged from the study of these resonance waves. They move with different speed, depending on the type of liquid in the rock. It appears that tight rock, water, and oil-filled rock each has distinct seismic resonance signatures. This makes it possible to distinguish tight rock from wet reservoirs and oil-filled reservoirs. Rather than the conventional way of looking for good conditions for oil presence, this resonance-based technology can identify direct oil signatures to improve the de-risking process significantly. The technology, Rex Virtual Drilling, has since been further refined and proven. Now let's see it in action. This is the Balder field on the Norwegian continental shelf. It is one of many fields where blind tests using available conventional seismic data covering existing, well-documented wells have been analyzed with Rex Virtual Drilling. Here, at a depth of 2,000 meters, we will take a closer look. Rex Virtual Drilling allows us to add an actual oil signature to our mapping of the prospect. This is done by classifying the Rex Virtual Drilling responses into categories. Here we have first identified resonance wave responses that are very unlikely to contain any oil. We have marked these in blue. The green indications define areas where an oil signal is present yet weak. Resonance waves that have clear oil signatures are depicted in yellow. These have a very high likelihood of containing oil and can now be added to the overall mapping and de-risking of the prospect. This is how Rex Virtual Drilling makes a difference. The technology can identify the oil signal directly from the seismic data, providing valuable information in addition to the structural geological analysis. These areas in yellow are the areas where Rex Virtual Drilling sees oil signatures, being nicely coherent with the sand reservoir mounts in the field. Now let's compare the Rex Virtual Drilling results with real drilling data. The yellow oil indications at the location of well 2511-8 match the oil discovery made. Likewise, the blue indications at the location of well 2511-1 match the well drilling results, which in this case came in dry. Looking at the whole concession, the results are conclusive. The wells in this survey that Rex Virtual Drilling identified with positive oil signatures were discoveries, and the wells with negative oil signatures were dry. In practice, where Rex Virtual Drilling sees strong seismic oil signatures, there is a higher chance of a discovery. And where it indicates tight rock or water-filled reservoir, drilling should be avoided. Rex now offers the technology as a service to oil companies around the world. It's a cost and time-efficient tool in the exploration, appraisal, or production phase to increase the chance of success and reduce risks and expenses dramatically. Contact us today for a detailed demonstration. Rex. Change the game.